Limit of a function. Aside from graphical and numerical method of finding limits, we also have the analytical method. Commonly, we make use of the concept of direct substitution. However, it is not applicable to all. So in that case, we make use of other techniques in evaluating the limit of a function. First, let's start with the basic limits. Let b and c be real numbers and n be a positive integer. First, let's have the limit of a constant b as x approaches to c is equal to b. Example, limit of 3 as x approaches to 0 is 3. The limit of negative 2 as x approaches to 1 is negative 2. The limit of 4 as x approaches to negative 2 is equal to 4. Second, we have the limit of x as x approaches to c is equal to c. So here, the direct substitution is applied. Example, limit of x as x approaches to 0, so we simply substitute 0. The limit of x as x approaches to 1 is 1. The limit of x as x approaches to negative 2 is equal to negative 2. Third, we have the limit of x to the n power as x approaches to c is equal to c to the n power. Direct substitution is also applied here. Example, limit of x squared as x approaches to 0, so direct substitution, 0 to the second power is equal to 0. Second, you have limit of x to the fourth power as x approaches to 1. 1 to the fourth power is equal to 1. Lastly, we have limit of x cubed as x approaches to negative 2. So you have negative 2 to the third power is equal to negative 8. Let's have the properties of limits. Here we have scalar multiple, sum and difference, product, quotient, and power. For scalar, if there is a constant in a function, we simply multiply the constant by the limit of the given function. If it's sum or difference, we also have to simply add or subtract their limits. For multiplication, multiply their limits. For quotient, divide their limits, but make sure that the denominator is not 0. And for the power, if the function is raised to a power, then the limit is also raised to the same power. Here we have the limits of a polynomial and rational. Basically, direct substitution is applied. You just have to make sure that the denominator of a rational function is not 0. Example, we have here the limit of 4x squared plus 3 as x approaches to 2. If we apply direct substitution, then the answer is 19. Second, we have the limit of x squared plus x plus 2 over x plus 1 as x approaches to 1. If we apply direct substitution, then we get 2. Next, we have limit of a function involving radical. Here, we will still apply direct substitution. Example, limit of the square root of x squared plus 4 as x approaches to 0. So direct substitution, then we get 2. Second, we have the cube root of 2x squared minus 10 as x approaches to 3. So we do direct substitution and then we get 2. Next, we have limits of trigonometric function. Example, limit of tangent x as x approaches to 0. So direct substitution, tangent of 0 is equal to 0. Next, we have the limit of x times cos x as x approaches to pi. Direct substitute, pi times cos pi is equal to negative pi. Third, we have the limit of sine squared x as x approaches to 0. So, we have sine 0 raised to the second power is equal to 0.